Hey guys, in this video I'm going to be teaching you the basics of Python so you can start writing Python code today that uses variables, if statements, loops, data structures, and functions. If that sounds good to you, let's get started. What is going on, you guys? I'm super excited to do this video for you guys because actually in a previous video one of you guys requested that I teach beginner Python. Now in the future, if there are any topics that you want me to go over with you guys, feel free to leave a comment and I'll try my best to make that video for you as soon as possible. Now in this video, we're going to be going over basic Python, so basic primitive data types, as well as if statements, loops, and we're also going to talk about the basic data structures such as arrays, dictionaries, and sets, as well as how to combine them all together into functions. So in order to start writing Python code on your computer and running it, you first need to download Python from python.org. So as you can see here, I'm on python.org/downloads, and here I can click this button to download Python 3.9.1. If this is your first time writing Python code, then I would also recommend that you download Visual Studio's code as your text editor. If you go ahead to code.visualstudio.com, you can go ahead and download it here. And I'm currently working on a Mac, but if you're working on Windows, it will give you the corresponding link to download the application for Windows. Now once you've gone ahead and have both of these downloaded, go ahead and open up Visual Studio's code and create a new folder. I've gone ahead and created this new Python folder on my desktop, and then all you have to do is go ahead and drag this Python folder into your Visual Studios. And that will essentially open up that folder in Visual Studios. To verify that, you should see your folder name over here on the left side. Now down here, you'll see that I have a terminal open. This is where we're going to run the command to run our Python code. In order to open this, you can just press Control tilde on either Windows or Mac. So if I press Control tilde right now, then it opens up a new terminal. And also up here at the top, I have the option to open a new terminal from the toolbar. Now to verify that you've downloaded Python 3 correctly, just type Python 3 space -- version. And if you hit enter, it should show the working version of Python that you have installed on your computer. Now that we have everything set up, let's go ahead and create our first Python file. So in order to do that, go over here to your Python folder and click New File. And then you can name your file whatever you want. I'm just going to name mine script, and then you do .py. Because that is the file extension for Python. So now to make sure that you've done this correctly, go ahead and open up your Python folder and you should see the script.py that we just created in Visual Studios. Now a couple things that we're going to be using a lot of in this tutorial are comments and print statements. So I'm going to go over those first. The first one that I talked about is a comment. And so there are two ways to do comments. The first one is just by doing a hashtag, and then you can type whatever you want after the hashtag, and when you run the code, it will ignore these lines. Comments are super useful if you want to add extra descriptions that help explain your code better, or also if you want to enable or disable lines of code without having to delete them. Another way that you can do a comment is by doing 3 double quotes in a row, followed by another set of 3 double quotes. Now anything that you type in between these 2 blocks of quotes will also be a comment. And this is how you can do multi-line comments. Now the other thing that I wanted to start off by mentioning is print statements. And this is how we can get our Python code to print something out in the terminal. And the key word to print anything out is just print. Now print is a function, and we'll talk a little bit more about functions later, but in order to invoke it, you have to put opening and closing parentheses. And in between the parentheses, you can put a value that you want to print out. So for instance, in here I can put in quotes the word hello. And if I go ahead and save this, and down here if I want to run my Python code, then I'll have to do Python 3 space and then the name of my Python file. In this case, I've named my file script.py. Hit enter, and you'll see that my Python code gets run, and it prints out the word hello because we've specified that on line 10. Now, print statements are super useful to see if your code is running and verify results along the way. So the first thing that you have to understand about Python is that there are 4 main primitive data types, and they are integers, floats, strings, and booleans. And let's go ahead and give examples for each of them. So an integer is a whole number, meaning it can't be a decimal or a fraction. That's where floats come in, because floats can be decimal numbers or partial numbers. If you watched my previous JavaScript video, you'll remember that one of the primitive data types for JavaScript is number. And numbers consist of both whole numbers and decimal numbers. But in Python, they have 2 separate primitive data types for each. The next primitive data type is a string, and strings are characterized by any characters that you can put in between double quotes. So for example, in our print statement on line 10, we printed out a string, and that string had the word hello inside of it. Now strings can also contain special characters, like an exclamation mark, And you can even put numbers in between quotes, and those would be considered strings instead. Now the last primitive data type is a boolean, and boolean values are binary, meaning they can only be one of two values, true or false. Now how do we actually use these primitive data types? In Python, we have things called variables, and variables can store values. So in this case, let's go ahead and create our very first variable. In Python, it's as easy as creating a word and setting it equal to the value that you want to assign to it. So in this case, the equal sign is an assignment operator. The thing on the left side is being assigned to the value on the right side. So we're assigning my first variable, which is our variable, equal to the integer 5. And what we can do to verify this is we can print out first variable. And if we go down here and run our Python code again, then we'll see that we print out the value that's stored in first variable, or the integer 5. Now, if you're ever unsure of the type of a variable, you can use a special function called type. So inside of our print statement, let's instead print out type of first variable. Save this, and let's run our code again. And we'll see that because of line 21, we'll print out the value stored in first variable, but we also print out the type of first variable because of our print statement on line 22. Now type is a function, as you can see, denoted by the opening and closing parentheses, and the value that you put in between the parentheses is first variable, which is the variable that you want to know the type of. Now in this case, in our terminal, it returns class int, which verifies that first variable has been assigned to an integer data type. Now let's go ahead and do the same thing, but this time we'll do it for a float. So as you can see here, I've now created second variable and assigned it to the float data type with a value of 5.0. On line 25, we're going to print out the value that's stored in second variable, and on line 26, we're going to print out the type of second variable. If we go down here to the terminal and we run python3 script.py and hit enter, then we see we run our Python code and we print out 5.0, which is the value stored inside second variable, as well as the type of second variable, which in this case, it says class float, whereas last time it said class int for integer. If we go ahead and do this again with third variable, and this time we assign it to a string and we run our code, then we see that we print out 5 because that's the value stored in third variable, but the type of third variable is now class str, which is short for string. And lastly, we have our fourth variable, which is a boolean. Now, booleans can only be one of two values, like we said before, and it has to be a capital T true or a capital F false. If we go ahead and run our Python3 script again, then we'll see that the fourth variable prints out the value of true, and it also prints out the type class bool, which is short for boolean. Now that we've talked about the four primitive data types, let's now talk about how those data types can interact with each other. So let's go ahead and create a variable a, and we'll set that equal to 5, and we'll create another variable b and set that equal to 10. Now what we can do is we can create another variable c and set that equal to a plus b. And now we can print out the value of c. Now the value of c should be the value of a plus b. Now the value of c should be the sum of the value stored in the variable a and the value stored in the variable b. If we go ahead and run our code again, then we'll see indeed it prints out the value 15 because a is 5, b is 10, so c must be 5 plus 10. And then if we go ahead and also print out the type of c and run our code again, we'll see that c is also of class integer. So whenever you're doing addition or subtraction between integers, then we know the result is going to also be an integer. The 5 main arithmetic operators that you're going to encounter are plus, minus, multiply, divide, and mod. Now the first 4 might sound familiar to you. You can imagine how you would add, subtract, multiply, or divide numbers together. But the last one, modulus, is essentially the same as remainder. For instance, if we were to create a variable d and set that equal to 10 mod 3, we're essentially saying what's the remainder when you divide 10 by 3. So in this case, if we print out d, we'd expect it to print out the value of 1. If we go ahead and run our code down here, we indeed get the value of 1. To show you this again, if we change the value of d to 12 mod 3, then 12 divided by 3 has no remainder, so we expect the value of d to print out 0, which it does. Now something to keep in mind is depending upon which arithmetic operators you choose to use, your result might be of type integer or of type float. Let me give you a quick example. Here, if we go ahead and create a variable e and set that equal to 1, which is an integer, and we create a variable f and we set that equal to 1.0, which is a float, and g is set equal to e plus f, what do you expect to happen when we print out g and type of g? Well, if we go ahead and run our code, we'll see that g prints out 2.0 and it says that the type of g is a float. So even though e was an integer, when you add it to a float, the result becomes a float. And the same thing happens if I change this addition sign on line 56 to a subtraction sign. If I run my code again, we'll see that our result is 0.0, and the type is also a float. So anytime that you do an arithmetic operation between an integer and the float, the result is going to be a float. But there's also actually one case where you'll use an arithmetic operation between two integers, and that will return a float. And that's when you do division. So here I've created variable h, and I've set that equal to integer 10. And I've also created variable I and set that equal to integer 3. Now if I divide h by I and set that equal to j, and we print out j, and we also print out the type of j, then we see that j is set to the value of 3.33333, and the data type of j is class float. So this is just something to keep in mind when you're doing operations between integers and floats. The result of the operation might be an integer, or it might be a float, depending upon which operations, as well as the types of the original variables used in the operation. The next thing that I want to show you guys is how you can have strings interact with each other. So let's create a variable k and set that equal to a string. And we'll go ahead and create another variable L and set that equal to a different string. Now if we want to concatenate these strings together, we can use the plus sign operator. Now it's possible to put these strings next to each other and assign it to another variable. So if we create variable m and we set that equal to k plus L, and we print out m and we run our code, then we see it prints out hello, nice to meet you. So when you use the plus sign operator, but both of your variables are strings, then that plus sign operator becomes a concatenation operator, which basically means it appends the second string variable to the first string variable. And if we also print out type m, then you'll see that the type of the result, m, is also a string. Now something interesting happens when you use the concatenation operator when only one of your variables is a string. For example, let's create a variable o and set that equal to the number 5. And let's also set a variable p and set that equal to the string hello. Now if we go ahead and try to add these two variables together, what do you expect to get printed out? If we go ahead and run our code, we see that we get an error. And then this error, it says unsupported operand types for addition sign between an integer and a string. So we are unable to add together a string and an integer because Python's not sure what to do with that. Now in order to fix this, what we can do is we can cast variable o into a string. And in order to do that, we'll type str, and then we'll wrap our o variable within parentheses. And that essentially casts our integer type into a string type. If we go ahead and run our code again, then we now see that our result q is 5 hello, and the result type is class string. This can work the other way as well. In this case, we have variable r, which is set equal to the integer 5, and variable s that's set equal to the string 10. Now, if we tried to add them together, we would get an error because it would say one of them is an integer and the other one is a string. But we can cast our variable s into an integer by wrapping this in this int caster and then wrapping our s variable in parentheses. Now if we run our code, we'll print out the result of t, which is 15, and it says that t is of type integer. However, if I flip this around and instead of casting variable s into a type integer, and instead we cast variable r into a type string, and we run our code again, then we see this time instead it concatenates 5 to 10 and returns the string 510, which is of type string. Now the last data type booleans is especially important because we're about to talk about conditions. With conditions, you might be familiar with the term if statement. Here I've created a very simple example of an if statement. I've created a variable u and assigned it to the boolean value true. And on line 9, I've written the if statement to say if u, then do the stuff that's tabbed in. Now the indentation in Python is super important for denoting which code lies within certain conditions. So in this case, this print statement right here lies within this if statement. Let's go over an example really quickly. So if we go ahead and run this code, we'll see that it prints out hi. And the reason is because this statement that's inside of the if returns true. Because it returns true, we end up running the code that's within the if statement, which is this hi. If I change u to be false instead, and we go ahead and run our code again, then we see this time we don't print out the string hi. And that's because this u condition inside of the if statement is false. However, if I create this other print statement, which is after the if statement, and we run our code again, then you see it prints out after if statement. And that's because that print statement is not indented to be within the if statement. If I were to tab it inwards, then this means that this print statement is now within the if statement. So if I run this again, nothing gets printed out, because u is still false, and this print statement does not get run. Now in if statements, it's possible to chain along multiple conditions, and you can do that using an elif statement. So here I've created an elif statement, and inside of it I said if v is less than w, then print out blue. In this case, I've created a variable v and set it equal to 5, and a variable w and set that equal to 6. Now this else if statement only gets run if the previous if statement fails. So if we go ahead and run our code here, we see that we print out blue. And that's because u is false, so we go to this next statement, and because this statement is true, we end up running the code inside of that elif statement. But if we go ahead and change u so that it's true now, and we run our code again, then we see we print out high, and it completely skips over the elif statement. Now the last thing that you can do is you can write an else statement, and this will only run if all the previous conditional statements result in false. So let's say we go ahead and change v so that it's the value of 7, and we also make u false. So if we were to run through the code mentally, we see in this case u is false, so we skip this code block. And next, because v is 7 and w is 6, v is no longer less than w, so we skip this code block. We now reach this else statement, and we will print out pineapple. And if we go ahead and run our code in our terminal, then we see we indeed print out pineapple. However, if any of the previous conditions evaluated to true, then we would run the code that's in that associated code block. Now in this previous example, we talked about the less than operator, but there's several other comparison operators as well. For instance, the double equal sign compares equality. Remember how previously we said that a single equal sign is the assignment operator, which essentially means we are assigning the variable on the left side to the value that's on the right side, as we did here on line 90 through 92. However, as soon as you use double equal signs, you're now comparing them together, and the result is a Boolean. So for example, if we go ahead and change our code so that now, instead of a less than sign, we have a double equal sign, and we run our code, we see that it prints out pineapple. And the reason is because u is false, but also v does not equal w, because v is 7 and w is 6. However, if I change w to 7, and we run our code again, we see we print out blue. And the reason is because v now equals w. So this evaluates to true, and we run the code block that's inside the elif statement. Now likewise, you have the not equal operator. In this case, you replace one of the equals operators with an exclamation mark instead. Now if we change w to 6 and we run our code again, then we see it returns blue because w is 6, v is 7, and w does not equal v. And down here you can see besides the less than comparison operator, you also have the greater than comparison operator, the less than or equal to comparison operator, and also the greater than or equal to comparison operator. In addition to the comparison operators, we also have logical operators, which are the keywords and, or, and not. These can be combined with your comparison operators to create even more complex logic. Let's go through a quick example. Here I've created 3 variables, x, y, and z, and assigned them to 10, 11, and 12 respectively. Now in this if statement, I have if x is less than y and y is less than z. Now in order for us to run the code block within this if statement, both of those conditions need to evaluate to true. So if we go ahead and run our code at the bottom, we see it prints out hello because x is less than y and y is less than z. But let's say we now change z equal to 10. So now y is no longer less than z. If we run our code again, we see that it doesn't print out anything. And the reason is because this condition in this if statement failed. And both of them need to be true in order to print hello. However, if we change this and to an or now, in order for this code to print out hello, only one of these conditions need to evaluate to true. So either x needs to be less than y, or y needs to be less than z. In this case, x is less than y, so if we run our code, we see that we print out hello, because even though y is not less than z, x is less than y. So that's why we run the code block inside the if statement. However, if we now change the value of y to 10, so now x is not less than y, and y is still not less than z, and we run our code, we don't print hello because both of those statements evaluate to false. And the last logical operator is the not operator. So in this case, we have a new variable AA, and we've set that equal to false. And inside this if statement, if AA is true, then we print out red. So if we go ahead and run our code in our terminal, then we see it doesn't print out anything. And that's because this condition right here evaluated to false. However, if I add the not keyword in front of it, then now it basically reverses whatever the Boolean value is of AA. So if we run this code again, we see we do print out red because now we're saying not AA, or not false, which evaluates to true. And thus we run the code block within the if statement. The next thing that I want to talk to you guys about are called loops. Now loops are a way for you to run the same code multiple times in a row. For example, here I've written a for loop which says for I in range 5, print out high. Now the way that this works is the number that I put inside of the range here is the number of times that this for loop runs. So if we go ahead and run the code, then we'll see it prints out high 5 times because we said for I in range 5. However, the way that this actually works is that for each iteration of the for loop, the value of I changes. So if instead of printing out high, we print out the value of I, and we go ahead and run our code again, then we see for the first iteration of the for loop, I is 0, and then I is 1, then it's 2, then it's 3, and then once it's 4, that's the last iteration of the for loop. So the way that range actually works, it runs the for loop for as long as I is less than this number inside range. In this case, we set range equal to 5. So it runs for 0, 1, 2, 3, and 4. Now, if you provide two numbers within range, so in this case, let's say we do 5 and 10, then this means that I is going to start at 5 and run all the way until I is no longer less than 10. So if we run our code again, we see I is 5, then 6, then 7, then 8, then 9, and 9 is the last number that I can be before I is no longer less than 10. So for loops are great if you know exactly how many times you want your code to run. However, what if you want your code to just keep running until a certain condition is met? That's where while loops come in. So here I've created a while loop, and outside of the while loop I defined a variable, bb, and set it equal to 1. And for the while loop I set the condition while bb is less than 10. So for as long as bb is less than 10, it will keep running all of the code within the while loop. Remember, code that's inside of a loop is code that's indented after you make the loop statement. So in this case, if we go ahead and run our code, we see that bb starts out as 1 and prints out its value all the way until bb is 9. Because at that point, when bb is 9, we increase bb by 1, and bb is now 10. And when bb is 10, 10 is no longer less than 10, so we break out of this while loop. Now this syntax right here essentially means I want to assign this variable bb equal to the original value of bb plus 1. So if bb up here is equal to 1, and we say I want to add 1 to that value, then we're now assigning bb equal to 2. Now the next time that we run the while loop, bb is set equal to 2, so 2 is less than 10, so then we print out 2. And then now it's 2 plus 1, so bb is now assigned the value of 3. And because 3 is less than 10, then we print out bb3, and then we add 1 to 3, so now bb is equal to 4. And that's how our while loop runs. And just like with if statements, you can have and, or, not, as well as any of the comparison operators inside of your while loop. Now the next thing that I want to talk about are the data structures to complement your primitive data types. Now data structures get their name from what they do. They are essentially complex structures that store data. Data can include primitive data types that we talked about before, like integers, floats, strings, and booleans, or other data structures. So the three data structures that we're going to talk about are lists, sets, and dictionaries, and each of them have their own unique purposes. So let's talk about how to use each of them. So the first one is going to be a list, and the way that you initialize a list is by creating a variable and setting it equal to opening and closing square brackets. Now a list is essentially like what you would imagine. It's a list of various data types. So you can add things to the list and you can remove things from the list, and all the things in the list are going to be ordered. For example, if we wanted to add something to the end of the list, we could do mylist.append and put in the string apples. Now if we go ahead and print out mylist, save that, and we run our code in the terminal, we'll see that we print out that list that contains the string apples. If we go ahead and add another append statement before we print out the list, so now we have apples and eggs, and we run our code, we see that our list contains both the string apples and eggs. If you wanted to remove things from your list, you could use a function called pop. So we would just do mylist.pop, and that function will remove the last thing off the list. So if we print mylist again, and we run our code, we see the first time it prints out mylist, it prints out apples and eggs, but the second time, eggs has been removed. Now if we wanted to take the value that we removed from the list and store it somewhere, we could assign it equal to a variable. And now what we can do is we can take that variable and use it however we want. So if we run our code again, we'll see that we have apples and eggs, and the list after we've removed eggs is just apples, and we also have this variable popped off that now holds the value of eggs. Now, like I mentioned before, our lists are ordered, which means you can reference the individual items on the list by using an index value. What I mean by that is apples is the first thing on the list. So if you use the index value of 0, then you can get the value of apples. And all the subsequent indexes on the list are just going to be +1. So for example, here, if I print out my list and I use square brackets and I put the value 0 in here, this is going to print out the very first thing on my list, which is index 0. So if I go ahead and run my code in the terminal, then you see it prints out apples. If I want to get the second value that's inside my list, I can change the 0 to a 1. Now 1 is going to reference the second thing in the list, because 0 is the first thing in the list. So if we run our code again, we're going to print out eggs, because eggs is the second thing in the list. Now if I go ahead and append a third item to the list, milk, and I want to reference that item instead, I can put the value 2 inside of the square brackets. And if I go ahead and run my code again, you'll see now we're referencing milk. What's also great are arrays are part of the class iterable in Python, which means you can write a special for loop to iterate through these arrays. So the original way that we would loop through my list would have to be writing a for loop where we say for I in range len, which is a function to get the length of the list of my list, and then we would print out my list at index I. So if we go ahead and run this code in the terminal, we see we print out each of the individual items inside of my list. But there's another more simpler way that we can write this. Here I've written a for in loop, where I specify a variable name here, and this can be whatever you want, and you say in your iterable. And then you can just print out your variable. So if we go ahead and run this code, we see it does the exact same thing. But it's a lot simpler because we don't have to reference the indexes. Food is just going to be assigned each of the values that's inside of my list at each iteration of the for loop. And for any of these data structures, they can hold any of the primitive values inside of it. So for this example, we did all strings, but we could instead change this milk to be an integer. Then if we go ahead and run our code again, then we see our array can hold both strings and integers at the same time. The next data structure that I want to talk about is sets, and the special thing about sets is that it can only hold unique values inside of it. Let me show you. So first we have to create our set, and the way that we do that is by creating a variable and setting it equal to set and then 2 parentheses. Now if you want to add things to the set, you can do myset.add, and then you can put a value inside of it. So if we go ahead and print out myset in the terminal, then you see our set contains the values true, eggs, apples, and 7. Now, unlike lists, sets are unordered, which means even if you added values to the set in this specific order, that order is lost when you print out the set. Whereas if you remember when we printed out the list always maintained that same order. So let's actually go back to our list for a second, and let's add apples a couple times. If we go ahead and run our code, then we see that our list contains apples 3 times, and then it has eggs and the number 1. But then what happens when we try to add apples to our set 3 times? If we go ahead and run our code, we see apples is still only inside of the set once. And this is because of the special property that I talked about earlier. Sets cannot contain duplicate values. However, as you can see with lists, lists can include duplicate values. Now, just like with lists, if you want to get how many items are inside of your set, you can use the len function. And in this case, because our set contains true, eggs, apples, and the number 7, our set length is 4. Now, something else with sets is you can use the keyword in to verify if a value is already inside your set. For example, if we were to print apples in my set, it would return a boolean as to whether apples is inside of your set or not. So if we run our code, we see that returns true because apples is in the set. But if we change apples to grapes and we run this again, we see that returns false. So this in keyword is very useful if you want to use it in a conditional if statement. And lastly, if you want to remove something from the set, you could just do mySet.remove and then the value that you want to remove from it. So in this case, we're going to remove apples and then we're going to print mySet again. So if we run our code, we see the first time that we print out mySet, it has eggs, 7, apples, and true. But the second time that we print out mySet, we've removed apples from it. So it only has eggs, 7, and true. Now the last data structure that I want to talk to you guys about is called the dictionary. And the dictionary is going to be very similar to the object in JavaScript. Essentially, a dictionary is a data structure that stores key-value pairs. So for a dictionary, you can assign a key to always return a value. Let's go through an example. So to create our first dictionary, we just create a variable and set that equal to opening and closing squiggly brackets. So here, to add a value to the dictionary, you need to provide two values, a key and a value. Now the key goes inside of these square brackets, similar to how we were using the index with a list. And the value is the thing that you put to the right of the equal sign to assign to that key. So if we just go ahead and print out my dictionary, we see that we print out this dictionary which has a key apple and the value pi. Now if we wanted to get the value pi out of dictionary, then just like with the array, we'll use square brackets and we pass in apple. And if we run our code now, we see that our print statement prints out the value pi because we passed in the key apple to our dictionary. So I've just gone ahead and added a couple more key value pairs to our dictionary. Here we have the key happy, which will give the value true, the key go, which will give the value bears, and the key blue, which will give the value 42. So if we want to get any of these specific values from our dictionary, we just pass in the specific key that we want. For example, if I pass in the key blue and I run my code, then it spits out the number 42. Now just like with sets, the keys in the dictionary have to all be unique, because the only way for you to assign a value inside of a dictionary is to know what key you're assigning it to, and it's not possible to have two keys that are the same. Also, just like with sets, you can use the in keyword to verify if a key exists inside a dictionary. Unfortunately, you can't do the same thing with values. So if we go ahead and run our code here, we see that returns true because blue is inside of my dictionary. However, if I change this to purple instead, and we run the code, then we see it returns false. And the reason is because purple is not a key inside of my dictionary. Now, if you wanted to get all of the keys inside of your dictionary, you could use this function called keys. And if you add that to the name of the variable for your dictionary and you run the code, you can see it prints out an iterable list of all the keys that are in your dictionary. In this case, we have apple, happy, go, and blue. If you wanted to get a list of the values, likewise, instead of keys here, you could put values. And if you run the code here, then you get another iterable list. But this time, it's only a list of all the values, which is pi, true, bears, and 42. If you want to remove something from your dictionary, then you have to use the del keyword, and that stands for delete. So here, we're removing blue from our dictionary, and then we're going to print out the dictionary. If we run our code, we see the first time that we print out the dictionary, it has these four key value pairs, apple pie, happy true, go bears, and blue 42. But after we've removed blue from my dictionary, it prints out just apple pie, happy true, and go bears. And you can see the key value pair for blue has been removed. Now the last topic that I want to talk about is functions. And functions are a great way for you to run the same code in multiple locations without having to write the code multiple times. Let me show you a quick example. So the way to create a function is to use the keyword def, and after this is the name of the function, and you can name it whatever you want. After that, you're going to need two parentheses. You're also going to need a colon, and all the code that goes inside the function is going to be tabbed inwards. So in this case, let's just have this function print out hello. Go ahead and save this, and if we run our code, we see that nothing happens. And the reason for that is because this is just a function definition. In order to run the code that's inside the function, you have to call the function somewhere else. So here, we'll just call say hello with the opening and closing parentheses, and now if we run our code, then it calls the function say hello once and prints out hello. Now I can go ahead and just take this and duplicate it as many times as I want, and if I run my code, it will essentially print out hello the number of times that I ran this function say hello. So you can essentially think of a function definition as a rubber stamp, and every time you stamp this somewhere, it runs the code inside of the function. This can be really powerful when you combine it with for loops and if statements. So not only that, but functions can also take in things called parameters. So if we create another function, and we'll just call it addition, And inside of the parentheses, we're going to pass in two parameters, a and b. Now what's great about this is I can take these two parameters and do whatever I want with them inside of this function. So in this case, I just want to print out a plus b. And now down here, I have to call my function. So if I do addition, and I pass in 1 and 2, save that, if we run the code in the terminal, then we see it prints out 3, because it takes the value of a, which is the first parameter, the value of b, which is the second parameter, and it prints out the sum of them. So here in my function call, the parameter a is assigned to 1, and the parameter b is assigned to 2. Now I could go ahead and I could call this function multiple times and pass in different parameter values. And if I run my code now, you can see I didn't have to rewrite this function definition multiple times, and yet when I pass in different parameters, I can print out different values. Now something to keep in mind is the ordering of these parameters actually matters. So for example, let's say instead of addition, we're going to do hugs. And here we're going to print out a hugs b. So if we go down here and we call our function, and we're going to pass in John and April, if we go ahead and run our code now, we see that because John is the parameter a, John is substituted in as a, and April is substituted in as b. And that's why it says John hugs April. However, as soon as I switch this around and I say April is the first parameter and John is the second parameter, now John is parameter b. If I run my code again, now it says April hugs John. And this is just a very simple example of how you could write a function and have it do different things by passing in different parameters. Now functions, you can also have if statements and for loops inside of them as well. And you can also have functions call other functions inside of them. So that's all I have for you guys in this video. Hopefully now you feel more comfortable setting up Python on your computer and running a little bit of code yourself. If there's anything more that you guys want to learn about Python, feel free to leave a comment down below and I'll try to make a video for it in the future. If you like this type of content, please consider subscribing and I'll see you guys in the next video.